Hello viewers, in today's session we are going to discuss an important problem from limits, and here we have to evaluate this limit. Limit extends to 0, 1 minus 2 times x raised to 10 raised to pi over x raised to 10 minus x raised to 10 divided by pi. So now to evaluate this limit here we'll adopt a special technique, right? And let us first discuss the technique or the process which is going to be used here to evaluate this limit. So now let us consider a limit of this form, that is limit x tends to a, and if we have two functions, say f of x and g of x, such that f of x is raised to this function g of x, right? So now if we compare these two limits, then we can see that this limit is of this form. So f of x is given by 1 minus 2 times x raised to 10, and g of x is given by pi over x raised to 10 minus x raised to 10 over pi, and here the value of a is given as 0, right? So whenever we have a limit of this form, and here we'll also see the conditions. If we have a limit of this form, then we can evaluate this limit by using a technique, and that technique can be used if two conditions are satisfied. So the first condition is that limit x tends to a, f of x must be equal to 1, and the second condition is that limit x tends to a, g of x must tend to infinity, or it is not defined, right? So whenever we have this type of limit and these two conditions are satisfied, that is limit x tends to a, f of x is equal to 1, and limit x tends to a, g of x tends to infinity, then the value of this limit, let us call this limit as L. So the value of this limit L can be given by this expression, that is e raised to limit x tends to a, and here we have g of x multiplied with f of x minus 1. So let us call this limit as L, right? And we can see that the given limit is of this form. And let us first satisfy these two conditions, right? So here we are considering limits of the form 1 raised to infinity, because limit x tends to a, f of x is 1, and limit x tends to a, g of x tends to infinity. So these type of limits are of the form 1 raised to infinity. So let us first find this limit, that is limit x tends to 0, f of x, here a is 0 and f of x is 1 minus 2x raised to 10, right? So first we are calculating this limit, that is limit x tends to 0, f of x. So here we can see that the value of this limit is 1 minus 2 times 0 raised to 10. Here taking x is equal to 0. So this is 1 minus 2 times 0, that is 1 minus 0 is equal to 1. So this condition is satisfied by this function 1 minus 2 times x raised to 10. So now let us see the second condition. So here limit x tends to 0, g of x, and we have limit x tends to 0, g of x is given by pi over x raised to 10 minus x raised to 10 divided by pi. Now see, here x is in the denominator and here x is in the numerator, right? So this limit is 0. So we have simply limit x tends to 0, pi over x raised to 10 and 0, right? So now this is the limit x tends to 0 pi divided by x raised to 10. So now when x tends to 0, then 1 over x tends to infinity, and similarly 1 over x raised to 10 also tends to infinity, right? So this limit tends to infinity. So now in the given limit, we have f of x as this function and g of x as this function. And both these functions satisfies these two conditions. So now the value of this limit is given by this expression, that is L is equal to e raised to limit x tends to a g of x, and here we have f of x minus 1. So now substituting the value of g of x and f of x in this expression, so the value of this limit L is given by e raised to limit x tends to 0, and g of x is pi divided by x raised to 10 minus x raised to 10 over pi, and here we have f of x 1 minus 2x raised to 10 minus 1. Now this one and this one get cancelled, so we have e raised to limit x tends to 0, and we have pi divided by x raised to 10 minus x raised to 10 over pi, and here we have minus 2 x raised to 10. So now we can take this minus 2 in front of the limit notation. So we have e raised to minus 2 limit x tends to 0, and we have pi divided by x raised to 10 minus x raised to 10 over pi, and here we are left with x raised to 10. So now multiplying x raised to 10 with these two numbers, so we have e raised to minus 2 limit x tends to 0. We have pi over x raised to 10 times x raised to 10 minus x raised to 10 times x raised to 10 divided by pi. So now these two terms get cancelled here, and here x raised to 10 multiplied with x raised to 10 is x raised to 20. So now we can write e raised to minus 2 limit x tends to 0, and here we have simply pi minus x raised to 20 divided by pi. So now this limit, that is limit x tends to 0 pi minus x raised to 20 divided pi, this term is now 0, right? Because here we have only pi and it is independent of x. So here when we take x is equal to 0, then this expression is equal to 0. So the value of the limit L is now e raised to minus 2, and here we have pi minus 0. So this is equal to e raised to minus 2 pi, right? So viewers, the value of this limit is equal to e raised to minus 2 pi. So this is how by this method limits of the form 1 raised to infinity can easily be evaluated. But here two conditions are important. The first one is limit x tends to a f of x. This limit should be equal to 1, and the limit x tends to a g of x must tend to infinity.